All right. Hello, hello. We are back at our nonsense again, making some NPCs for VR chat. I've been fiddling with my fan here, actually. It shouldn't be coming over the mic, but I have noticed that my character's mouth still moves just from the fan. But maybe I'll be flapping my mouth open and close a bunch that it might not even matter. You will hear me drinking though. Make sure you have water by you. Alright, so last week we set up some automation for creating the NPCs, and this week we're going to be doing some stuff with those NPCs. Let's tell. Now, I'll admit, there was a little bit that oh, hello, Lumi. I'll admit there was a little bit that I did between streams. It was largely just some cleanup of some things here and there. Yeah, I'm glad you like it. I think we've got, let's see, 6 minutes in. This is, I believe it's Wii Fit. I could be wrong. But yeah, definitely something from a game I've played, so it's probably Wii Fit. That was definitely the family exercise game growing up. Alright. So one of the things that I did set up between streams was a udon version of dynamic bones, just so these the character's hair and clothing can move around a bit. It's not the best, but it is passable, and will be included in this project. So, if we just look at, there we go. There's a bit of swooshing going on for their coat when they're moving around, for their hair as well. This one has a bit of a mix because the hair automatically bobs during animations, but also has a bit more swoosh to it just from that. So you can see it moving around like there. And then the box Unity-chan has the, I called them hinge bones, set up on basically their whole spine on up. So whenever they rotate, all of their blocks kind of pivot around and move over. I don't know how well it scales. I've basically just tested it on these 4. Well, 3 because they don't have any hair. And it seems to be working. Wiggly. Maybe in the future I will have it be something that's like on its own, but for now it will be part of the NPC project we got here. Alright, I took some notes here so I actually know what we're working on today. Alright, so the first thing that I wanted to set up was a stage for following the player. Right now, the NPCs have 3 different states. Their states are hidden behind me, so let me rearrange my inspector here a bit. Alright. They have the pathing state, they have the tracking state, and they have the idle state. Idle, they just stand around. Tracking, they track a specific game object and constantly follow them. And pathing, they follow these specific paths. Now, I'll break that out in a bit, but I think I have some ideas of how to expand that out. Hi there, been using your assets for some VR chat modes. I'm using the inventory assistant and wondering if you are planning to add some sort of persistent system since the persistent update is out. So I have actually very recently updated the inventory system. I have not put out a announcement for it, but it isn't using persistence. And the reason why is because everything in the world that's like a synced object just can be owned by anyone. So if you had something in your inventory previously and you come back and you load into a world and someone already has that item in your inventory, I don't know how to handle that. What I can do is I can implement it for local items, but I don't think I'll be able to handle it for synced items. It might be possible that I can just say, if nobody is currently storing this item, then inventory it in yours. And there's definitely options, but I'll have to figure out what's like the friendliest for the user, because no matter what I go with, it's going to be weird in one way or another. You are not the first person to ask me that. But I think it's possible. It will just take a bit of figuring out. That makes sense. Yeah. I do need to do a proper write-up for the updates now, because I did do a pretty big back-end update for it. It isn't forward compatible, so well, it isn't backwards compatible, so you essentially need to redo your scene for inventory stuff to swap over to the new version. But it supports world inventories now as well, so you can have a crate that you can put an item into, and then you can press a button and your menu links to that crate instead, and you can pull items out of it. And that's I'm pretty happy with how that one came out. That was actually largely a commission by one of my friends who wanted to use it for a large RP world that they had. Crates? I'm interested. Yeah. So essentially, you can have what's called a world storage, which is just a button that acts as a, like, open the menu with this storage ID. So instead of the previous system where there was a synced bool on every game object that was like, is this stored or is it not? Because that's all anyone really cared about. What it does now is it stores a ID of what storage it's in. if it's in a player inventory, we just use the player ID, which is always 1, 2, 3, or the likes, and it's always a positive number. World storage units, just storage containers or the likes, use negative numbers. Yeah, this is all part of the new update. Previously it was just a bool, but now there's an integer handling the syncing for what storage units it's in. And there's some examples in it as well. Actually, I should be able to... maybe I can open it up here. Let me... Actually, I could just briefly add the package to this project. Valgan pickup inventory. Apply. Boom, boom, boom. Give it a little sec. You don't see the pop-up, but I have the completing domain loading thing. There we go. Alright, so now we can go to packages, Valgan pickup inventory. Let's go to runtime, demo, inventory. Oh, import TMP essentials. There we go. Let me reload the scene so these text things actually properly propagate. There we go. Hide TMP icons. So what you'll see over here is a button that says open inventory. And this is just a UI button, and that pings to there we go. World storage UI. So there's two prefabs for it. There's a world storage here and a world storage here, where this is a game object you click on, and this is a UI button that you raycast to. And each one of them has a few things. It has the position where it spawns the menu, so just like a transform that's above it. A spawn point, which is just where the item that you have spawned from the menu gets placed. And then it has the actual canvas with the button and everything. But on the root object is the pickup inventory storage, which just shows the storage ID, which on this one it's 0. Which doesn't seem right. This should be below 0. When is this being set? Oh, right. It's set during the build process. Okay, yeah. This is glad you like. But yeah, similarly to the player inventory system, you can set what the starting items are. So if you want to have like 3 apples in this crate for some reason, you can just put them into this starting items array here, and it will automatically place those items into this array when the owner of the world loads in, or if they're local items, they get put in when you get there. It also now has a item max count, which can be any number, and if it's 0, it means that you can have infinite. There's no cap on it. But there's also a item size class. So max item size, this is set to large, but it can be extra large, it can be medium, it can be small. And this allows us to have different sized items. So like, let's say you have this hammer, and it wouldn't make sense to put this hammer in your pocket. Well, the hammer is set to large, and the player's inventory, which is right up here, local inventory, there we go. The max item size for it is medium. All of these values you can change, you can fiddle with, you can do whatever you want. And player inventory has max item count of 0 by default, so infinite. And this should give a lot more customization to that kind of stuff for like roleplay worlds, for games that you're setting up, or anything like that. It's cool, yeah, I'm glad you like. I really would like to get some kind of persistence added into it, especially for local items, but figuring out how to add persistence for synced items will definitely be a sit down and figure out what the best user experience would be to make that happen. Swap back to the NPCs here. Just go ahead and remove the pickup inventory from this. Get me some water. I think the big one would be persistence, especially if yeah, I would really like to add that. It'll definitely be me having to figure it out. Probably, honestly, I think the biggest one is just I need to go to people who are already using my system and ask them how they would like it to work. So music is good. Yeah, I've found a few great Nintendo playlists that I've kind of been homogenizing back and forth to kind of get exactly what I want, and it really kind of helps the mood for everything. I've really enjoyed the tracks that I've managed to pick out for this, and I'm glad you all are too. Alright, now for NPCs. So we're going to add a fourth state to these right now. So instead of idle, tracking, and pathing, we are going to add player following, follow player. Yeah, I think it'll just be player following. Player following. Alright. So we're basically going to copy the states for tracking, and I'm going to change this to player following. Instead of set destination target dot position, we are going to do we're going to get the player's position and then add that. Do we have local player on this one yet? We do not. Okay. So let's just grab the local player. All right, VRC player API local player. Start local player equals nope. Networking local player. And with that, we'll just grab the player's position. So Pt3 player position equals local player get position. Let me just put that into the... Now this is going to be a bit weird at first, and you'll see why pretty quickly. But with this setup, we can pretty much just head back into Unity here, and I'll kind of show you how it's working now. Let's just set everyone to state player following. Well, alright, so you see why it's a little bit weird. They all just kind of get as close as they can, and are just constantly updating their target to follow me. Their walk speed doesn't help. It's a little bit spooky with everyone kind of slowly walking towards you. But that's just the walk speed of the animation. Actually, this animation I think is being played at like 1.25 speed. So it's already a bit faster than default. But let's go ahead and set up some actual handling for getting this better. First of all, they need to not be going right at me. So what we are going to do is, instead of doing set destination, we're going to have a custom function that lets us pass in a stopping distance. So let's do private void. We'll do public for this. Set public void set agent destination. This will be Pt3 position and a float for radius. Now, the radius for their stopping distance is already something that we are controlling from our creation window. So we're going to basically use the same value, but we're going to set up how we handle that here. So let's go ahead and do private float stopping with 2 P's. Stopping distance, and in start, we'll do stopping distance equals, do we have a reference to the motion? Yeah, okay, locomotion. Oh, for doing that, okay, so in that case, instead of putting this function in the agent controller, we're going to put that into the agent locomotion here. So instead of doing position, we'll do position float radius. That'll break a few things here, but this should let us do agent dot stopping distance equals radius. Can I default this to an existing value? So we aren't immediately storing their stopping distance. So since we're writing that in the start, we can cache that. Let's do, since we're writing it during the NPC creation thing, private float default stopping distance. Default stopping distance equals agent dot stopping distance. So that would have to be compile time. Alright, so in that case, we will do another function that's public void set destination that just takes a position, and we use this to call set destination with the position and the default stopping distance. So now we have the best of both worlds. We don't actually need to always tell it a distance, and if we don't, it just defaults to whatever we already set. Alright. So let's get a hello, how's it going? Kyle94 Scoots. Awesome name. Let's do public float, stopping distance. And just have this return default stopping distance. That way you can grab this, and basically I think we'll just multiply that by 4 for following players. We'll parameterize that. So serialize private float player tracking distance. So we don't need that up here anymore. Let's go ahead and yeah. Okay. We'll just grab that. And I like player tracking better than player following. Let's do that. All right. So now they should all stop at a relatively reasonable distance. Yeah, okay, so that feels pretty good. And they won't start following again until I get a bit further away. And then they stop at that point. Okay. Alright. That feels pretty good. There's a few things that I can set up alongside this. So if it's following the player, one of the things that we might want is a, like, auto respawn feature. So let's break this up and have it not be happening once every frame. Since realistically, player's position, we probably only care about updating it about once every second. So we could put that into a send custom event delayed and just cast that with 1 second. That probably would make the most sense. And then we just check to see if it's not the player tracking state and then skip out of it. Okay. If we're gonna do that though, we're going to want to have a way for handling state change declaration. Because otherwise, if we're going to have the ability to swap different states and send custom events, queued events that worry about that, we need a way to call it once and not just constantly stack it. Yeah, I think it would be fine just to have a timer instead of doing sudden custom event delayed seconds. We'll do private float decision time. We'll do elapsed decision time. Player tracking update rate. Set that to 1. 80 seconds. Really long name, but I will much more gladly have a long descriptive name than a short non-descriptive name. We'll also have to check to see if the state has changed, because then we want to reset the elapsed decision time. So let's have a private agent state, old state. We'll just do that at the start there. So we'll call a new function, private void check current state. Check current state. If old state does not equal state, nope, that's start. Underscore state, that's it. We will do old state equals state, and then we will reset the elapsed decision time to 0. Let's do this as a run state block instead. So this handles the state changing, but it also increments the elapsed times. Elapsed decision time. We do time dot delta time since that's being handled in update. And the rest of update is our state machine. So let's do if the elapsed decision time is greater than player tracking update in seconds. The elapsed decision time equals 0, and then we will declare their new update. Okay. Alright, that should work. And we can take that, and if we head back to Unity here, we should see a noticeable point at which they update the new position if I increase this number a lot. So let's say I change player tracking update rate in seconds to 3 and just kind of run in a circle. Let's change this to player focused. Go into play mode here shortly. Alright. See, they're still going that way until they update to that target, and they go this way. There we go. And obviously we don't want this to be set to 3. I think setting this to 1 is pretty good. And maybe setting their distance to 2.5 so they get a little bit closer. 3 meters away probably will feel like a lot more when you're in VR rather than in desktop. That's one of the things that we noticed during the development of the NPCs for VCAT, is that if you have an NPC following you, it is very different spatially when they're following you in VR versus desktop. In desktop, you want them much further away because then your singular desktop view can encompass them a bit more, and it feels more natural for them to be further away. So in VR, the NPCs actually follow you slightly closer because that space is much more noticeable when you're actually in headset. But obviously we don't want them following too close, or then you're just feeling encroached on. That's one of the big ones for the desktop thing. Like, they had to be that far away, or they just felt like they were right next to you. Alright. So we've got player tracking. Now, next up, let's go ahead and add the directed statements. So this will let us come in later with a proper director system. And that'll let us kind of have an external system that declares the character should walk forward for 5 seconds, turn right, go backwards, and stuff like that. And if we build out those kind of systems, then we won't have to keep putting more and more stuff into the agent controller here. We can have different unique systems that direct the NPC to do different things. So let's go ahead and give it a directed state. And just duplicate this, directed, and just have it. It's not going to do anything. It's basically going to be the same as idle, except we'll be listening and declaring things. So if we go back into Unity, let's go ahead and make that director. So basically, it's going to need a few things. 1, it needs a way of triggering. 2, it needs a thing that makes the NPC do things. And 3, it needs a way to release the NPC back to a state. So let's go ahead. And I'll actually make a new fold. I think we encompass pretty much everything in one. So agent director. Sounds a bit more like a spy thing now. Go ahead, add this in. And we can add mesh agent. So we are going to need a agent controller for some stuff. Ebony, hello! How is it going? We are controlling our NPCs and telling them to go places. Or, well, that's at least what we're setting up. Well. So let's have this agent director talk to a specific agent. That's probably what would make most sense. Just give it a singular target. So let's do public agent controller agent. I'll call that target. Now, this is going to be a bit complicated because this is going to be one of those things that exists largely as a editor tool rather than an actual Udon thing. The result is going to be a big series of arrays and everything piled up like that. So this is probably going to be a lot of editor tooling first and foremost. How do we want to do that then? Well, let's set up some base data types. So we'll have a public enum, agent direction, and let's set up just the most basic directions that we already have. Wait and set destination. Now, if we want to do that, we're going to need two things. One, we need a float for how long we want to wait, presumably in seconds. And two, we need either a Vector3 or a transform for, let's go with a transform, for the destination that they're going to go to. So we're going to need that for every direction. And since we want to be able to do multiple, let's go ahead and make arrays for all of these. So we'll do public agent direction array directions, public float array wait durations, and a public transform. There we go. Array, transform array set destinations. All right, and from here on out, it's going to be editor scripting, baby. So let's make a custom editor for this. Pop into our editor folder here. New C# script, agent director editor. Pop on the namespace there, editor class, and custom editor type of agent director. And since we're perfectly fine using UI elements for this, we're just going to do exactly that. Let's go ahead and do create GUI, so create inspector GUI. We are going to add the I'm a GUI container for the Udon sharp header. Let's get a root set up here. So visual element root equals new visual element. And just going to return that here at the end. Root.add sharp header. And Udon sharp header dot on GUI handler. That's going to take the Udon sharp GUI raw default Udon sharp behavior header and just pass in a target for that. Just move it here to the left. So this basically gives us the same header that all Udon sharp behaviors have, with all the options, the compile button, and everything. But now we need to fill in the rest of it. So we're going to do inspector element dot fill default inspector. We pass in root. We'll target our serialized object and pass in this for the editor. So we should go back to Unity. We should put a director on something, and we should see that nothing has changed except we lost our spacing on the left. So let's go ahead, do director, and yep, it all looks fine except we lost our spacing here on the left. That is easy enough to fix. We just need to figure out what the styling is for this. And fortunately for me, I recently did a video on this. So I can actually just look at the code that I did for that video and snag that. Alright, here we go. So we need to add these three classes in order to make it work. Unity Inspector Element, Unity Inspector Element UIE Default, and Unity Inspector Element UIE. those are the three styles that basically all inspectors are have for the default implementation of everything. So now this looks identical to how it does by default. Technically not perfectly identical since this little field is here, but we don't really care about that. We're going to be rewriting a lot of this. So let's go ahead and come up with our fake data class that will encompass all of this stuff over here. So we'll do a public class agent direction data. So this is going to contain basically any version of this that we can, and we just grab the data that we actually want from it. So this will have a public agent direction, a public float, wait duration, and a public transform, set destination target. And I'll rename this over here to targets. We'll set this to be serializable so it can show up properly in our stuff. And let's make a list of it and make a list view for it as well. So public list, we'll do agent direction data, directions equals new. And this doesn't really need to be public. This is on a private inspector, so there isn't actually any use to having it being public at the moment. So we're going to go down here to list view, direction list equals list view. We'll add that to the root, so root.add direction list. And we will do direction list dot source, item source, here we go, equals directions. Now, if we head back into Unity, eventually, it says list is empty. Oh, okay. So the list view by default doesn't have very many options, settings in it. What we can do is enable basically all of them. So let's go ahead, initialize members. We're going to honestly ignore most of these, but there's a few that we are going to keep. Don't care about flexible. Honestly, we don't care about most of the things that it inherits. We want selection type single. We don't want you to multi-select for that. Selection index, we're not going to write that. Show border will be true. Reorderable will be true. Horizontal scrolling, we don't care about that. Alternating colors, I like setting this to all. Virtualization method, fixed item height, these I don't care about. Show bounds collection size, that just gives us the number box on the top right, so true. Show fold out header, true. Header title, directions. Add remove footer, just the plus and minus, will be true. And reorder mode will be animated. I'm going to keep our declaration of the item source separate down here. It can go up in here, but for the most part, this is a pretty specific thing that we're going to be doing more with. So I'm going to keep that separate from the base initializer. Alright, so now we have a little pop-up for this. Now, you see it says null here. We're going to have to actually add in some stuff. So when we do directions list items added, we're going to basically tell directions.add range in the direction of length in dot length. Okay, this is getting that's not it. Dot count. There we go. So whenever an item is added, we add an item to the bottom of it. For some reason, items added comes back with ints, which is like an enumerable thing. I wonder if it's the... Oh, it might be the indices at which it's trying to add something. Okay, so let's break this out a bit more. So for each int index, I'll do directions.add insert? Yeah, insert. So we'll do index there and then new agent direction. Instead of doing that. And direction list dot remove items removed. You're going to do basically the same thing in reverse. Alright, and we'll do these in reverse as well, quite literally, just in stop verse, so that we can add things at the end and then increment back in, so it doesn't run into any kind of order of operations thing. So we'll do the same thing and do remove at, and the only thing we want to do is index. There. Now if we pop back into Unity, it should be not null. Alright, well one of them is a null. Why isn't this creating a real thing? So this isn't intercepting, this is... Yeah, this isn't replacing, it's just intercepting. So this is being inserted on top of it. I thought doing that would replace this. Let's look at the debug values. Oh wait, it's part of the inspector, so... It's going to be a bit wonky if we do that. So it might just make the most sense to break it out into a scriptable object that we then store on this. And those are the directions that... Well, no, because then it won't properly reference scene objects. Like it would work for dialogue wait times, but it wouldn't work for destinations that we're telling it to go to, since that is a world space transform. Oh, how do we want to do that? I just wish I knew a bit more properly, like, why this is adding a null value in, instead of the actual one that I've set up here. You know, I'm gonna Google it. Unity list view, add null. Maybe it has to do with list view source, source list, item source. Okay. Change item source, how to get list view child. Can you use new UI toolkit? Add null. Well, I could do the cheaty way of just having an invisible component. That it stores everything on. I could technically do that. That might make the most time functional sense. Yeah, that might be what I have to do for now. Okay. We'll do that for now, and if I end up finding a way to properly handle the null value additions here, might make this a bit more sense. Is there like a type that I can cast into it? I just don't know why. It's doing that. Oh well. Alright. Let's go ahead. Let's get our director set up with a agent director helper component. Agent director helper. And this is just going to store our data in the friendly way. I could technically break this out a bit more. Yeah, I could do that, but it would get really messy really quick as we add more and more things to this. So for now, we'll just do this. On validate, we'll set flags equals. We'll do not editable for now, but we'll set this to hidden eventually, so that we never actually see this component. It's just a hidden required part of the director thing here. And we'll have a target for it, so do public agent director target. And when this is destroyed, we want to remove this thing as well, so we'll do if target equals null, destroy this. Just clean that up with the lifetime check. And in here is where we're going to be moving basically all of this. So this is going to be a custom editor for our agent director. And our agent director is now going to do require component type of agent director helper. And this is basically all being done just to store these values. What did I do wrong? Alright. For now, we'll just get rid of that. So if we go back to our director, there we go. We have a agent director helper there. We're going to do two things here. So If target is null, we'll do target equals wait, no. Can a model behavior have a parameter-based constructor? It should, right? So public agent direct helper value a float thing. I don't actually. All right. The only reason that I was doing any kind of elaborate checking here is because if the user tries setting up more than one director on a single game object, it would get wonky. But I think we can just manually limit that. It's like disallow multiple components. That should keep the user from being able to put multiple ones on the same object. We'll do target equals get component agent director. No, director, not direction. And if target is still null, get rid of this. You can also just do on destroy here and wrap this in a if unity editor and not compiler udon sharp. Pop that in. We can get rid of it like this. So agent direction. Nope. Agent director. God, I cannot spell. Helper equals get component, and if helper destroy, I can do destroy immediates, I think. No, I think destroy is the one we want. There we go. So when you remove this component, it should also remove this over here. And this has a backup check, which we probably don't need. I'll get rid of it for now. So target component agent director. So if we head back here, the target field on this should actually be this up here. Yep, okay, so we have that thing there. Let's go ahead and remove that. This is still here, so removing a component doesn't do that. So let's go ahead and double that up. Target's valid, return. Otherwise, try to get the target, and if not, destroy it. So as soon as compiling is done here, it should get rid of this component. Unvalidate, I believe, is when values change, so oh, does the not editable flag also keep me from removing it? Let's just not do any flags for now. We'll be hiding this eventually, so it doesn't really matter. Alright, remove component. Drag on the agent director. Get this helper that shows up. Remove. And still doesn't get rid of it. Um. Hmm. Destroy component when removing another component. Let's see what the internet's got for us. I say we can use editor stuff to what was that? Oh god, what do we use? Well, doing this inside of the gizmo handling probably isn't the right thing to do, but it would certainly be a function that's running when visible. Let's see. On validate, editor only function that Unity calls when the script is loaded or a value changes in the inspector. I'm not sure what the loaded part means because sometimes it seems to work, sometimes it doesn't. Because obviously it's not destroying itself. Validate is called various stages during the editor's normal operations, such as loading scenes, building the player, and entering play mode. You should not use this callback to do other tasks, such as create objects or other non-thread safe Unity. Okay. I guess onValidate isn't run on the main thread of Unity. Huh, okay. Good to know. Alright. Well, for now I won't worry about this too much. In fact, honestly, I can just get rid of this. So, let's go ahead. We got our list here. So, we go to our director in Unity, and drag it onto the component. Should be able to, just set it up. Alright, so got that there, not there. The issue wasn't that it was private, was it? I'll do a quick try on that. This shouldn't do it. What? Yep, no, okay, so it's still adding null values into it. Alright, so that wasn't it. So I can go ahead and remove that. Alright, so our public directions here is going to be doing all this stuff. And again, this is just going to be data storage for when we are doing things for the editor. This component will be removed during the build process. There we go. You see, we have all three of the proper values here. We have the specific direction type, we have the duration awaiting, and we have the set destination target. Now, if we want to actually do things with this in a way that's sensible and reasonable, we're going to have to set up some oddities here. So we only want to show wait to duration when wait is selected, and we only want to show set destination target when set destination is selected. So what we are going to do is we're actually going to create a custom visual element that we're going to use for handling the list view. So I'm actually going to move all of our director stuff to a folder since we're getting multiple scripts for it now. So director, dragging this stuff over to that. Make a new editor folder in here as well. And we'll drag the agent director editor into this one. But we're also going to do our custom visual elements in here. Agent direction field. Alright, so instead of doing a mono behavior, we are going to inherit from a visual element. And we're going to have a bunch of fields inside of this. So we'll do a constructor for it. So we'll do a public agent direction field. If I can spell it all, oh my god. And we will bind this to a serialized property. So serialized property. No, we don't want to pass in the property right away. This is we're going to have a separate one for public void bind property, serialized property. And this is basically going to be a visual wrapper for our agent direction data over here. So we're going to need 3 things right now, and they're all just property fields. So private property field, direction field, wait duration field, and the set destination. Just to speed up editor friendliness, I'll basically just have all these match the capitalization of this over here, just so I can copy paste a bit easier. So we're going to do direction field equals property field, wait, duration field equals new property field, and set destination target field equals new property field. Each one of these are going to be added to this, so this dot add direction field, this dot add wait duration field. Hello, hello Necatron. Yes, I am back, and I am doing well, I was doing NPCs, and now I'm doing editor nonsense. We're a few layers deep at this point, but I'm basically building a system for giving NPCs directions. And that's going to let us actually kind of control them in a user-friendly manner. It just requires a bit of coding that is, well, it's certainly happening. I can say that much at least. this dot add, set destination target field, and bind property. We're gonna bind all the values to that. So serialized property. Prop direction equals property dot find property relative name of, and this will be agent direction data. No, I don't want that. Don't we have this in the helper? Okay, we'll store that outside of the class there. We'll get rid of it from the editor here. There we go. Duplicate that 3 times. Get rid of field there. And at the end of every one of these, we'll do dot direction. We'll do wait duration and set destination target. So what this is doing is we're grabbing the child properties of the one that we're passing in. What we're doing is we're going to pass in the property of this agent direction data over here. So just like for each value in this list, we're going to build one of these fields. And each of these variables has these 3 values within it: the direction, the duration, the destination. And we're breaking out those variables here, we're just kind of asserting they exist. And now we will bind them into these fields up here. So direction field dot bind property, and we will pass in prop direction. And duplicate that. Grab wait duration and set destination target. But we need to actually use this somewhere. So right now we're not using it. We will do that not in our creation window. We will do that. Agent director editor? Yeah, this should be it. So this director is going to be grabbing the fields from our helper. So we need to assert that the helper exists. How do we want to do that? Private, private serialized object, serialized helper. And we'll just grab that and automate. Serialized helper equals target dot. We need to cast that. We could probably store it as well. Wouldn't be bad. But agent director. And I just always call this script. It's just the script that it's targeting. Script equals target as agent director. This is just like a save cast. So doing as instead of the like parentheses with this. If you do it this way and this cast fails, it errors. But if the cast doesn't fail here, if the cast does fail when you have as, it doesn't error until you try to use it. And there's some use cases where that's beneficial. I just like the semantic sugar of target as agent director. So serialized helper will be new serialized object of script.getComponent helper. And now it's complaining that it's possible that this could be null, so okay, fine, I'll just cast it. All right. We have our serialized helper now. Now we actually need the list property from it. So I'll drag this over here so we know exactly what we're doing. Do a private serialized property, prop directions, and right after we get this serialized helper, we'll do prop directions equals serialized helper dot find property name of. That'll be agent director helper dot directions. All right, we can take that, and that is what we are going to bind to our direction list here. So direction list dot bind property, pass in directions. Now, if we want to actually use this field, however, we're going to have to intercept some of the events for how list views handle data. So we're going to do direction list dot make item, and we will return a new agent direction field. There we go. So the make item function here is just when the list creates a new item. And list views, the way list views work is they recycle elements. So when you scroll down, an element from above will be reused below. And that can be pretty useful at times, but it also means that automatic cleanup is a bit less, well, it's pretty reliable, but there's some times where it can be a bit wonky. But for now, I think our situation should be fine. So now that we've made it, we need to actually bind it. So fortunately, our list views have a bind property callback, so direction list.bind item. And so this gives us a visual element and an index. What we are going to take from this is we are going to assert this visual element is a agent direction field. So agent direction field equals agent direction field casted over element. And we'll do field dot bind property, and we will pass in prop directions, get array element at index I. Since I is the exact index, oops, that's not supposed to be the bind, that's supposed to be bind property. There we go. And this gets us the specific one that this one's going to show. And now, now's the fun part, where we see if any of this code that we just did actually works. The unfortunate thing about all of this code that I just did is currently it will do exactly the same as we had before and won't be noticeable in there being a difference. Oh wait, no. Okay, so this is working. The height for it is not dynamic, as you can see. As I slide this around, this is changing the ones up here. So if I set this to be some values and I swing it around up here, suddenly they get turned around down here. And if I flip it, subsequently they flip up here. All right, that is good. There should be a dynamic height. Isn't there a dynamic height option? Let's quickly check this here in the UI builder. So if I drag out a, where is a list view in this? Here we go, list view. Just put in the roots up here. Reorderable selection, virtualization method. Oh, it's virtualization method is okay. Virtualization method equals dynamic height. Collection virtualization method is not something that implicitly makes sense to me, but I'm sure there's some explanations for it. All right. In that case, if we head back into Unity and I leave full screen here. Yeah, okay. So now you see basically the same thing as up here, where all these are showing up at once. But we would need to actually do stuff with this. So the reason we split all this out into the 3 fields is that when our direction field changes, we want to enable and disable a few other things. So it'll be a void show fields, and we want to show fields based on a enum value from our helper. Wait, no, we want agent direction, which is in an agent director. Or agent direction. Now, annoyingly, enabling and disabling the visibility of a field isn't just like set enable or set active. You have to set the styling to a specific thing, and you can't just pass in a bool for it. So in a lot of projects previously, I've set up extension methods for that. And I'm just gonna do it manually with I think it's ternary, they call it. So we're going to switch statement actually no, we don't even need to switch statement this. We can just do direction field dot style dot visibility. No, visibility isn't right. Display, that's it. So in here we can pass display style. Scroll up a bit. We can do display style dot flex, which is show, and display style none, which is height. What we are going to do is set this value based on a ternary check for a direction value. So direction equals weight. All right. So if we do that, the direction field will only show up if direction equals weight, because if it does, it'll use the first thing here, and if not, it'll use this one. We don't actually want to do this because our direction field is the thing that lets us change directions. So I'm going to change this to the weight duration field, and get our set destination target field, and set this one to set destination. So this is a bit more legible. I'll just drop that down a layer. And we need to do the show fields the moment we bind property. And we can do that by grabbing the enum value from the property here. Which means that I should probably store these up here. Cut these ones off. We can fix the naming on these. And I want to have a auto grab for direction type. So let's do private direction current, and this returns prop direction dot enum index, I think is the right one. And we cast that here, and we just call show fields current. Now, the reason this lets us actually control everything is right now, it does this the moment that we bind the properties, but if it changes this field, it won't do anything. So we need to do an onChanged for this direction. So direction field dot change, register value change callback, and this will call show fields. And in here, EVT is our event's new value. So we're similarly going to cast for that. So cast agent direction EVT dot. See, this is a property field, so the return value is very generic. I think we should be safe to just do current, because I think by this point it should have written the new value in. And if not, well, honestly, I think I can swap this to be an enum field instead of a generic property field. But we can check here. So let's go ahead. Visual element, blah, blah, blah. All right, wait shows wait duration. And set destination. Okay, awesome. So that does work perfectly fine. While I have set destination shown up on this one, it shows the set destination target. And if I swap that to wait, it changes this to a float. And these two fields exist, they're just hidden when we aren't needing them. And we can grab anywhere on the left to drag up and down. Awesome. Okay, this is coming along perfectly. Alright, what more do we need to do for this? Well, I mean, one, we need to actually implement the director instead of just its editor. But I think we can go ahead and, let's see, we can close that for now. Agent director, helper. We'll do the onValidate for this to make it invisible. Flags, hide flags equals hide in editor. Oops, nope. Hide in inspector. There we go. That shouldn't get rid of these values. Okay, yeah, so this is still visible. We can still set these to whatever we want. Nice, nice. Alright, so now that we have this, we need to go through and compress that. So we'll do that in post-process scene. So director post-process scene. Post-process scene, honestly, my favorite function in Unity. It's just one that runs when you are either going into play mode or building the scene for any other reason. And it just lets you really automate so many things. So I'll do public static void on post-process scene. This can realistically be called anything, but I just do that for legibility. And we give it the post-process scene attribute. And we'll make it go at -10 so it runs before VRChat. So we are going to find all of our directors. So agent director. Directors equals find objects by type. Pass in agent director. And we want to include the inactive ones. And we don't care about order, so we'll sort by none. Now, for each director, let's assert so that we have a helper on it. Helper equals director.get component helper. If the helper is null, just continue. Skip it. One of the dangerous things about post-process scene though is that while it can't irreparably harm your project, it's always like in the build process. It's never writing into your files themselves. What it can do is, if it ever fails, if it ever hits a null or like an errors out in any way, it stops the build process. It leaves play mode. And if your tooling has a chance of failing, you just locked up someone's project somewhere. So you always need to have your stuff completely fail safe in the event that this kind of tooling is being shown. All right, so we need to get the values from the helper over into the director. So if we look at our helper, we have a list of directions on it, and yeah, we don't need this target on it. Okay, so we're gonna go and make an array of directions. So honestly, I can just copy these here. And honestly, I'll replace this from array to being list so that we can append into it properly. There we go. Now we can, for each helper dot directions, directions dot add direction. Wow, that is probably the least legible line of text I've ever written. Okay, you know, yeah, this needs to be changed. This will be direction type. Okay. So direction types, and change that to direction types instead of just directions. Oh god. Yeah, that. Ugh. Anyway, wait durations dot add direction dot wait duration, set destination targets dot add direction set destination targets. Then here at the end we go director dot direction types equals direction types dot to array. Duplicate that. Apply these in. And since we don't want the script causing any weirdness during the build process, we will get rid of it. So we will destroy helper. Let's go ahead and put our director here. We won't actually be able to see the helper be destroyed, but we should see... Oh. Okay, so if the helper is destroyed, these aren't going to be here anymore. So we only want to do this if we're going into a build. We don't want to destroy it if we're in play mode. So if editor application is playing, not. All right, then we destroy it there. All right, so if I hit play mode, all this should be fine. Nothing weird should happen, but all these values should be pumped into these three arrays here. Okay. Yeah, all three of these are properly filled in now. Nice. That means, actually, so to keep myself from being stared at, I'm going to tell all these guys to path around instead. Okay, so yeah, now we can actually have our director start directing an NPC. What we need to have it do is tell a specific character to do something. I'm going to have it control Pikachu tape here. Just put it into the field up there. And actually, I'm going to sort these by order in this row. All right. So our director needs to start doing stuff. Don't care about the editor and stuff right now. I will close a few things here. Boom, boom. Agent controller, agent locomotion, post process. We can get rid of that. So we need our director to actually do stuff. All right. One of the big things about a director is you need to be able to tell it when to activate. There's 3 types that I really like using, and there's other ways that you can do it, but there's 3 ones that I find very useful. 1, when a player interacts with something. 2, when a player walks into a trigger zone. Or 3, when an NPC walks into a trigger zone. That's a big one as well, especially if you want a more natural thing to happen while an NPC is following you. So if there's an NPC that's coming with you to do something and you walk into a trigger zone, you don't want them to immediately start yelling, oh, hey, go look at this, and they run off there. You want them to come to that quote-unquote realization once they properly get to that area. So we're going to have another enum up here, which isn't agent interaction. We're going to do public enum direction trigger type to interact on player trigger enter on player trigger exit on agent enter on agent exit. Realistically, I think I can get rid of the word trigger in this one. Well, this function isn't working as it is, so I'll just get rid of it. All right. Let's see. Oh, the other thing that we need is whether or not it can fire again. Like say, do you want them to always jump when they walk into this area? Or if it's like a line of dialogue, you probably only want them to do it once. So we'll do public bool retriggerable. There's probably a better word than retriggerable, but that's what I'm using. So we'll do actually I'll just move it over here. Makes it a bit more readable for everyone involved. Public direction trigger type. Trigger type. On trigger enter. We're going to see if the target is the agent, and if so, we'll check this value first. If trigger type does not equal on agent enter, return. And I'll just queue that up in the other ones as well. On trigger exit. On agent exit. Next, we want to see if there's like actually the agent on the other side of this collider. Oh wait. Do Navmesh agents have their own handling for trigger collisions, or do I need to put a rigid body on them in a collider? That's a Google answer. Unity nav mesh on trigger enter Navish agent. Yeah, I think it's gonna have to have a collider and a rigid body on it. Should be fine. It's just a little bit more that I have to automate the setup for. Shouldn't be bad. One trigger enter. If other dot. We'll cache that here. Agent controller. Agent equals other dot get component agent controller. And if agent is null, I'll snag that for on trigger as well. And let's set this up for the on-player trigger enter as well. On-player trigger enter. Yeah, we'll do a local check. So if they're not local, skip it. I don't have to arbitrarily have a limit. I'll just have another set for it here. The trigger type is okay, we'll do the trigger type equals local. Oh, that's set up. No, I don't want to do that. Here we want to check to see if player.local return. We'll do else if trigger type does not equal on player enter return. So everything beyond here should fire either A, if it's a local player event and that is the local player, if I actually do that, or B, if it's not the local player or is, but is the on player enter function. My guess is the on player enter instead of on player local enter is going to be used a bit less, especially if syncing doesn't get implemented. We'll see if that does. So on player trigger exit. We'll basically copy this exactly, except for swapping the words enter for exit. And all of these are going to call public void trigger. And this will check two things. One, whether or not it's retriggerable, and if so, two, has it already been triggered? So, private bool triggered. If not retriggerable and triggered, return. otherwise triggered equals true. And then we do everything from there. Bonk, 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 and bonk. So in here is where we'll handle the actual triggering of things. I realize now we have 15 minutes after all that editor nonsense. But I think it's absolutely worth it for user friendliness. So we need to figure out where we're going about with this. So we need to grab the state the NPC was in. Yeah, okay, we'll do that. Or should we declare a custom one? We can do both. It'll be a bit more editor stuff, but it won't be stuff we'll finish today. So, public bool use previous state on complete, and if not, we'll do public agent state on complete. I'll just set the title. We'll use previous state on complete true by default, which means we'll have to cache what state they used to be on. So private agent state previous state. So trigger will previous state equals agent. What do I call this? Target. I'll call this agent. Agent dot state. Okay, we're gonna have to have a getter for that. Public state gets us state. And now we need to set their states to be directed. So public void set state, agent state equals state. This new state. There we go. Sometimes my code likes to have a lot of the same word, and all legibility breaks down immediately when this happens. So now we want to actually iterate through our stuff. So we'll do public void next direction step. And we need an index for which direction we're currently on. Private int direction index. We start with direction index ++, which means that before we call it, we need to do direction index equals -1, and next direction step. So if it's wait, we're just gonna do nothing and then call this switch. This is gonna switch between direction types, direction index. Log from that. So wait, if we're going to do that, we're going to call this function again after that delay. So we'll do send custom event delayed seconds, name of next direction step, and we'll do wait durations and grab the one from the current direction index. And set destination. For that, we are going to yeah, okay. So we'll do agent.locomotion.setDestination. And this will take in the set destinations target from our index. Direction index, there we go. Transform does not take it. Okay, position. There we go. So we'll just wait 1 second for this action to complete. So we'll swap this from seconds to be frames. So yeah, I didn't mean seconds. We will let 1 frame pass, and then this will push on to the next one. I found that's a pretty safe way of handling a lot of these NPC director stuff. Oh, I never implemented interact. Well, that was easy enough. Interact. Trigger. There we go. We need to check quick to see if we have reached the last direction. So if direction index is greater than or equal to direction types.light. If so, turn. If use previous state on complete, we will do agent.setState previous state. Else, we will do agent.setState complete agent state on complete. There we go. We could ternary that. I'm just gonna leave it like this, but get rid of the brackets. That should be good for now. All right. So now we can trigger this from a bunch of different ways. We're going to need collider and rigid body on our NPCs if we want it to actually be part of our automation and like trigger these things. All right, so this director, let's quickly set this up with some example actions. Actually, delete that. We'll just make a cube to 1.2, 0.50. That's just going to be our button. Walk up to this and click it. Agent director. Directions. I'm going to start by setting a destination. One thing that one of the downsides of using these send custom event delayed for this is it becomes much harder to listen for when the agent has reached its destination. So we'll have to implement that next time. But for now, we can set a destination. Just destination 1. Destination 2. And destination 3. So it's gonna do that. It's gonna wait 3 seconds. It's gonna set to wait. All right. Station 1, 2, 3. Wait. We're gonna tie this to Pikachu 2. Pikachu 2 is by default going to go into the player tracking state so that they're not too far away. And I'll set this to be retrigger. We should probably have the toggle for when it's active, but thing for another day. Alright, so this one here is the one we're controlling. If I click that, so what happened there? I think what happened is all these positions are like within enough of their stopping range that it didn't matter. These are all at 3, right? Yeah, so this should be 3 seconds. I'll just make these much further apart here. And I'll move them to the ground. It shouldn't be an issue, but in case it is. Alright, play. So the behavior expected is that they will walk up to us, we will click the button, and they will walk forward a bit, they will wait, they'll walk forward a bit, and they will walk forward a bit. What is happening here? I'm going to tab the game view up here so that we can get a better view of the actual debugging for the nav mesh here. It says that the current state is idle, but it's obviously tracking me. So if I do this, okay. So something's getting overwritten here. So set state, run state clock, zoom back. Basically, it's immediately overwriting the target destination with the one from the player tracking. And, well, that's sure not right. 2, 3. Yeah. Oh, something is constantly telling this to be vital. I can't change it anymore. new states being written to? New state. I wonder if it's an editor issue. I wonder if it's a root issue. I don't know. Because what we're doing is we're declaring what to do during different states. We have our directed state. Our director is... Oh, we're grabbing the previous state. We're not writing it. Agent, though, set state directed. Okay. That should be it. Let's give it a quick test here, and if not, I'll write it down as a thing to fix. And if so, yippee. Alright. So they're standing right next to me. Alright. They go to their destination. They go to their destination. There we go. That was it. That was all we were missing. Alright. And now they return to tracking me. Alright. Awesome. Okay. Well, now we have the basic structure of the director setup. I like this. It's actually working. It's a little bit odd that the director needs to be running stuff through a helper that we have set up on here. Not entirely sure why that's the case. I have some friends that I can ask about this. Because the issue was the list view was appending in a null value instead of a new value when we were storing the list here on the editor and setting this list view to have its source from that. This is technically easier to maintain in the future anyway, because this just uses serialized properties, and it doesn't have to be a million random things that are undo handling. There's things that I could do to break this up and just use the serialized properties off of the base script, but automating that during the build and having the helper component is just going to be so much easier to maintain. Alright, well, I say we got through quite a lot of things today. Oh, one of the things that I didn't mention is it's probably not super noticeable, but the specific animation used by the characters when they're walking around is different now. It's now using the Unity-chan default walking animation, which is, drumroll, redistributable, which means that I can actually, like, have animations included in this package, which means I don't need to strip out the animations that I'm using for this package, and it means that I can actually put it on Patreon. I wanted to put last week's package onto Patreon, but I ran into the issue of, well, the animation stuff aren't redistributable yet. But now that we're gone from Mixamo and we can use existing animations now that are only kind of not great, like they're fine. The movement is a little bit stilted because it's kind of a basic hand animation. If you watch the transforms specifically, their hips never move when they're walking, which isn't the most natural thing, but it's free. So it will be included in the package. I will box up what we've got today and put that up on Patreon today as what the NPC package currently is, and I'll do a write-up about the hinge bones as well, because as far as I can tell, there aren't really other Udon implementations of dynamic bones, fizz bones, spring bones, hinge bones, whatever. And this one works satisfiably. It can definitely be improved. In fact, it really needs to be improved in a few ways, such as not activating if the renderer isn't being viewed, and stuff like that. But you know what it is? It is a starting point, and my god is it a good one. And with that, we are going to be calling it for today. We got a lot of stuff done. I feel like maybe I was a little bit fast on some of it and just kind of focused and not chatting too much. More just describing everything that I was doing. But all things considered, I think it's coming along pretty good. Hopefully people will actually be able to start getting some use out of these NPCs and tell me if they're broken or not. They almost certainly are. They're not done. And there's going to be things that need to be improved in the future, like there isn't automation for putting colliders on yet, but eventually, TM. And with that, I think I shall bid you all adieu. Good seeing everyone this week, and I look forward to seeing people on Thursday, when we shall continue our adventure. Good seeing everyone. Take care.